You are welcome to episode 54, continuation of coordinate geometry. In this episode, we want to look at derivation of slope or gradient of a line in coordinate geometry. I want you to note that slope or gradient depends on the angle made by the line to the horizontal. That's the first thing. As a student, you must note that the slope or the gradient of a given line depends on the angle made by that line to the horizontal. This is what we are saying here. Let's call this one theta. So we want to derive the formula for slope or gradient of a given line AB. Now this place is change in y, which is as well equals to y2 minus y1, and also this place is change in x, which can as well be x2 minus x1. Now we know that tan theta, according to trigonometry, is opposite over adjacent. If that is the case, that means our tan theta will now be change in y over change in x. Like I told you that the slope depends on the angle made by the horizontal. So we can call this tan theta as slope or gradient, since it depends on the angle made with the horizontal. So therefore, I can say that slope or gradient is change in y all over change in x. And if it is further mathematics now, I can go further to make change in x to tends to 0. Whenever I make change in x tend to 0, then this one will be dy ds. That means the slope of a given straight line can easily be determined if we differentiate the y with respect to x. Now from here, we can say that slope is y2 minus y1 all over x2 minus x1, which is equal to which can be equal to m, the gradient. Now we can represent our gradient or slope as m. So let's go to derivation of equation of a straight line. Note that the slope at any point in time of a straight line will be equal to each other, no matter where you take the point from. The slope here will be equal to the slope here. So now, if this one is happen to be x2, y2, why we put this one to be x1, y1. Then let's assume that this is ordinary x and y. Now, if we get the gradient, what I'm saying is that gradient BC is the same thing as gradient AC. So if I'm going to have that, that means my y minus y1 all over x minus x1, the slope should be equal to y2, that is AC, minus y1 all over x2 minus x1. Remember that this is m, the gradient. So if that is the case, that means y minus y1 over x minus x1 is equal to the gradient. If I cross multiply, I will have y minus y1 equals m into x minus x1. Now if I open the bracket, I will have y minus y1 equals mx minus mx1. If I make y the subject of the formula, I will have y equals to mx plus y1 minus mx1. Then let me say that at the point of intersection, I can say that let C be equal to y1 minus mx, be a constant there, so that anything can be the intercept. The intercept will depend on y1 and x1. So I can say that equation of a straight line is y equals to mx plus c, where c is the intercept on y-axis when x is equal to 0. So let's call this one equation 2 of the equation 3 under coordinate geometry. Why we call this one equation 2 under the coordinate geometry. So until next episode, where we are going to be looking at midpoint under coordinate geometry, I want you to help us subscribe, at the same time share the video to as many as possible so that they can learn and also add value to their life. Till next episode, I want you to stay tuned and God bless.